Graph Creator 2 is the second part of basically a three-part series of projects where eventually we're going to be solving the traveling salesman problem. We're doing this in a series of stages because there's a lot to it, and so it's basically going to be broken up into a series of projects. So now that we have our basic graph creator, where you can actually place circles and nodes, and it has an adjacency matrix and all of that stuff, the next trick is to see if two nodes are connected in general. So if I run this, so if I create A, B, create an edge 1 between these two, node C, and edge 2 between B and C. And the question is there a connection between A and C? And actually the answer is yes. There's a series of paths that will get you there, even though there is no direct connection. Basically, two nodes count as being connected if there's any series of edges they could follow to get from one to another. So if I add in node D over here, and I say, is there a connection between A and D? The answer is no. The basic way we're going to tell this is we're going to have two text fields where we put in the two end nodes and a button which says whether or not they're connected. I think I'm going to put that on the right side of my panel. So let me start with that. So starting from my original graph creator, so I need another JText field. Let's see. First node. I'm just going to put in first for now so that they know what that is going on there. Second. And then I need a button. UJ button. So the idea is when I click on this J button, it'll check these two and see if they exist, and then if they have labels. I think I'm going to put this on the east side, just to separate it, make it a little easier to deal with. All right, so I have a grid layout. I think I'm going to do the same thing with east. Going to add the first one, this first node. Add second node. Going to add the connected button. And I'm going to add an action listener to that button. And then finally, in the frame, I'm going to add east to the east. Okay, so now if I take a look at this, I have it over here. All right, so let's see. What do I need to do next? Probably the next step is to actually figure out whether the labels that I've put into my text fields actually match any of the labels in my nodes. So at the moment, the graph panel is the thing that has that. He has a list of nodes, and by getting each node out, I can check its label and see if it matches. So I think that I'm going to have a function that's going to, I pass in a label, and it tells me whether or not that particular node exists. So this is kind of like getNode, only it's going to be based on a name. So maybe node exists. I pass in a string. And I'm going to return whether or not that label matches any of the nodes in my list. So I'm going to go through my node list. Node list.size. If s equals a particular one, so get a dot get label. I'm going to return true. If I get through everything and none of them match, that would be a false. So I'm going to use this to check to see if any of the make sure those two labels are valid. So right now I have an action performed if the source is the node button and the edge button. As a matter of fact, why don't I call this connected B for connected button, just to be consistent. And then down at the bottom, if the source equals the connected button, so then I'm going to check the text out of the first one and see if that's valid, and then the text out of the second one, see if that's valid. And if they both are, away we go. So if panel dot, what did I call it again? Node exists. So that'll be the first, so first node dot get text. So if that's false, then I'm going to have to pop up something. And then I'm going to check to see if the second node exists. If we get through both of those checks, away we go with our connection code, which will go here. So how do I do a pop-up? Probably the easiest way is something called a jOptionPane dot show message dialog. So the way this works is that you can pass in the frame. So the frame is frame, and then the message you want to show. First node is not in your graph. Done. Similar thing here. Second node is not in your graph. So let's give this a shot real quick. So I don't have anything in my graph at all, so I say, hey. Oh, yeah, that doesn't work. So I'll try node A and say, let's put node A in. Second is not in my graph. Now can I do it? Yes, now we're okay. All right, so now the connection stuff. The idea with this is I'm going to actually use my adjacency matrix to figure out whether or not they're all connected. The other thing I'm actually going to need for this is something called a queue. The idea is that every time that I have a new thing in my graph, so I have A, B, actually let's do this, C, edge 1 between those two, edge 2 between those two. So the idea is that when I put in A, I want to actually put in all the things that are connected to it. In this case, all I have is B, but I could easily have something like node D off here with an edge between it. So if I start at A and I want to see if C is connected, I'll put A into my list of things that I know are connected to A. Then I put each one of the nodes connected to that node into the queue. And the way the queue works is that it's a little bit like a stack in that you put things into it and pull them out again, except that whatever order they go into the queue, you pull them out in the same order, as opposed to a stack where you can only get the one that you most recently put on top. You can think of a queue more like a checkout line at a grocery store, for example. The order you go in is the order you get checked out. So I'm going to need a queue to keep track of this, and also just a general list to keep track of what all is connected together. So what I'm eventually going to have is I'm going to put in A and E, for example, E, and I hit test connected, and it's going to say they're not connected. A, D, B, and C are all connected in one graph, but E is off by itself. If I put in A and C, it's going to say they are connected, because A has a path to get from A to C.